Hello again, Year 6. Welcome to another Year 6 maths meeting. As always, you need something to write with and something to write on. Remember, we've got that new character of the week, so watch out for him. He's coming up again. We're going to kick off today with revising how many days there are in each month. We're going to do this together. Off we go. 30 days have September, April, June, and November. All the rest have 31, except February alone, which has but 28 days clear and 29 in each leap year. I hope you were joining in Year 6, because now it's time to pause the video and try it by yourself. Off you go. All right, now we're going to have a look at filling in some of these blanks. So pause the video and fill in the missing words or numbers. All right, let's see how you got on. 30 days have September, April, June, and November. All the rest have 31, except February alone, which has but 28 days clear and 29 in each leap year. Well done if you got those. Now remember these facts because we're going to need them to answer these two questions. October has blank days. There are blank days in March and September all together. Pause your video and have a go at those two. Okay, let's see how we got on. October has blank days. 30 days have September, April, June, and November. I didn't mention October. All the rest have 31 except for February. October has 31 days. There are blank days in March and September all together. 30 days have September, April, June, and November. I didn't mention March. All the rest have 31 except February. There are 31 days in March. So there are 30 days in September, 31 days in March, 61 days altogether. Well done if you got that, Year 6. All right, we're off to knowing what Noah knows now. Noah's going to use related facts to solve these equations which look more difficult than they are. So pause the video and have a go. All right, let's see how we got on. Now I can see in my first example, 32 divided by 4 is a related fact, and I know this. 32 divided by 4 is 8. But wait, we need to make the answer 10 times smaller because the question was 10 times smaller, 0.8. My related fact, 7 times 8 is equal to 56. But wait, we need to make it 10 times smaller, 5.6. Well done if you got that one, Year 6. All right, we're moving on to Fahim's factors now. What do the factors of 24 add up to? Pause the video and use the most efficient method to find these factors. Let's see how we got on. When I see factor, I draw bugs. Factor bugs are the most efficient way to list your factors. So we're going to list the factors of 24 and then add them up. Factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. These are the factor pairs for the number 24. Now all I need to do is add them together. I add them together to get a total of 60. The factors of 24 add up to 60. All right, we're moving on to Percy %, our new character of the week. Pause the video and write the 3 things that Percy knows. All right, let's have a look. Percy knows percent means out of 100. Percy knows the symbol for percent. Percy knows a percent is a fraction. So let's use Percy's facts to help us solve these two problems. 10% of 840, 5% of 840. Pause the video and have a go. All right, let's see how we got on. 10% is equal to 10 hundredths, 10 out of 100. And that simplifies to 1/10. If we're looking for 10%, we can find 1/10. 1/10 of 840, 84. Now Percy knows that 5% is half of 10%, and we've just found 10%. So 5% of 840 is 42. It's half the answer that I got for my first question. All right, let's move on. Priya's prime factors. We haven't done prime factors for a very long time, so let's refresh our memory. Prime factors. Prime factors. Let's look at prime. Prime, P-R-I-M-E. My only factors are 1 and me. A prime number has but two factors, 1 and itself. Prime factors. When I see factor, I draw bugs. I know factors are multiplied together to find a product, but I need prime factors. Let's see a reminder. A factor tree. Prime factors are drawn in a factor tree. All right, now we've had those reminders, pause the video and see if you can find the prime factors of 55 and the prime factors of 80. All right, let's see how we got on. The prime factors of 55. What I'm going to list now is a factor pair that multiplies together to make 55. I'm going with 11 and 5. 11 times 5 is equal to 55. Luckily, 11 and 5 are both prime numbers. They're prime factors of 55. So I list them as 5 and 11. Now let's have a look at 80. I'm going to start with the factors 2 and 40. They're a factor pair for 80. And the good thing about this is that 2 is prime, so I'll circle it as a prime factor. Now let's carry on with 40. 40 is not prime. 40 is composite, so I need to break it down into prime factors. I'm going to use 2 again. 2 times 20 is equal to 40. 2 is prime and a factor of 40, but 20 is composite. So I need to work on 20 now. I'm going to use the fact that 2 is still a factor of 20. 2 times 10 equal to 20, and 2 is a prime factor of 80. So now we need to look at 10. 10 is composite, so we need to break it down into factors. I'm going to use the fact that 2 is a factor of 10. And I've got 2 times 5 equals 10. Luckily, 5 is also prime. We can't do any more to this factor tree. We've broken it down into all its prime factors. So now we list them. I've got 5, 2, 2, 2, 2. They are the prime factors of 80. Look at all those 2's that I have. There's a much more efficient way to write it. I've got 5 and 2 to the power of 4. Those are the prime factors of 80. All right, moving on to Tilly times across now. We're going to multiply 5/8 by 7/8. Pause the video, off you go. Okay, let's see how we got on. Tilly times is across. She multiplies the numerators and then she multiplies the denominators. 5 times 7 and then 8 times 8 to give me 35/64. Well done again, Year 6. Great maths meeting. As always, you can go back through and have a look at those methods.